standard deviation calculates. What is the meaning behind these two terms? When you talk about any distribution, any sort of values, you see, let's say we have 5 different values, 6 different values, and you were able to find out, let's say, x, which is the mean. The mean of these 6 values is x. You know the mean, sum of all the individual numbers divided by the number of values. So mean is x over here. So what is the meaning of variance and standard deviation? What does variance and standard deviation do? They find out how much all these values are deviated from the mean, found out the difference between all these values, how much your values are dispersed away, how much your values are, far away from your mean, from your central position mean. So they measure dispersion. Of some random variable around its expected value. So my mean is replaced here with expected value. We just discussed what expected value is. Expected value and mean are, nothing but two synonyms. Mean mein what we do, we add each of the values and we divide it by the number of the values which we have. Expected value, similar thing. You multiply each value with the probabilities and add them up. In mean, why we divide them by the overall number of digits? Because we assume that the probability that each value will occur is the same. So that is basically 1 by the number of values you have. If you have 5 values, then 1 by 5. So variance and standard deviation. So what is the formula for variance and standard deviation? It is RA minus expected RA whole square So if you have an event into the probabilities, so let's say you have an event, boom, normal, and slow. Your economy is in boom, your economy is behaving normally, or your economy is in a slow mode. And you have probabilities. So we had started with reading 4. I have completed expected value till now, and we are continuing with variance. So you have, let's say your economy can have 3 types of states: boom, normal, and slow. The probability of your economy in being in these 3 states is 30%, 50%, and 20%. What is the return your investment will give in each case? 20%, 12%, 5%. So this is your question. Now, what is expected return of A? How do we find expected value of something? Expected value of anything is your value multiplied by the probability. So my return here is 20% and the probability of that return is 30%. So 20% into 0.3 plus 12% into 0.5 plus 5% into 0.2. So this is my expected return. What is the answer for this? Is 0.3, 0.1.3. Now, what was the definition for variance and standard deviation? How much your values are dispersed away from your expected values. That is, what are the random variables you are taking? Here, what are the random variables? 30%, 50%, 20%. We have our expected return, which is 13%. So, how much my random variables are dispersed away from my expected value? So, RA minus dispersed away, the meaning is what? How much are they far away? So, how can you find that? You can find out the difference, 20% minus 13%. For finding out the variance, you square it and multiply it with the probability 0.3. Similarly, 12% minus 13%. Square this, multiply it with 0.5. 5% minus 13% whole square into 0.5. So this will give me my variance of the return A, which is 0.00280. Now, why do we move from variance to standard deviation? I discussed that in the last class too, because it's variance. Whenever you talk about variance, the units are squared. Why the units are squared? Because of this square. Units are squared. If here you have percentage as the unit, your variance answer will have percentage square. So for the reader, it becomes a little difficult to interpret what does it really mean. So from variance, you go to the standard deviation. What is the formula for standard deviation? It is root over variance, return A, which is root over 0.00280 in this case. Clear? The ones who are listening, Dhruv, if you are attending.
Yes, ma'am.
Okay, so have you watched the previous recording?
Not yet, ma'am. I've just recently enrolled in the course, but I'm listening right now.
Okay, and when is your attempt due?
Uh, for CFA, probably November, not August.
Okay, perfect. So this was about variance and standard deviation. From here, we move on to the Bayes theorem. So you make a probability tree. That is, there can be two probabilities. Your economy can be in a good state or your economy can be in a poor state. The probability of economy being in a good state is 60% and in poor state is 40%. And if your economy is in good state, the probability that your economy will lead to good results is 30%. Poor results is 70%. And if in bad state economy, then good results probability would be equal to 60% and poor results would be equal to 40%. The EPS in each case is given. EPS here would be 1.80, EPS earning per share, 1.70, 1.30 and 1. So what is your expected EPS? What is the total expected EPS? How can you find it? You are sure that you are going to earn 1.8 only if your economy is in a good state, and even after being in a good state, your economy generates good return. So the probability of generating the EPS of 1.8 is what? 60% and 30%? The probability of generating 1.70 is what? Your economy is in a good state and then the economy generates poor returns. That is 60% into 70%. The economy is in a poor state, then the economy generates good return, then only the EPS would be 1.30. It is 40% into 60%. The economy is in a poor state and generates poor returns, 40% into 40%. Now, what is expected EPS? Expected value of anything is value multiplied by the probability. So, if you want to find out the expected EPS, what you will do? 1.80 into the probability of generating 1.80 EPS, adding it to 1.70 into this probability, 1.30 into this probability, 1 into this probability. So, the final answer will be your expected EPS, which is 1.51. Any doubts?
No, ma'am.
So what is Bayes formula? You consider Bayes formula when the accident already has happened. That is, in our case, what can be? The economy already has generated poor returns. Economy already has generated poor returns. Now tell me, what was the probability that the economy was in boom or in the good state? The accident already has happened. There can be three cases wherein, the accident can happen through bus, through car, through motorcycle. Now, the probability of accidents happening through bus, car, motorcycle is given. But now the question is reversed. The question is telling you the accident already has happened. Tell me whether the accident happened by bus or not. So here the question can be, poor returns already have generated. Tell me whether the economy was in good state or not. So if you want to find out such type of probabilities, Bayes formula helps here. What is the formula for Bayes? Any idea?
Is it the probability of A intersection B divided by probability of
A intersection B divided by?
probability of B? B
Yeah.
being the event that has already happened.
Okay, and what would be the equal to side? Probability of what?
Probability of A given that B has happened.
Okay. And how can you write A intersection B?
Could you repeat the question exactly, the details?
So let's see. Let's say your B is that your accident can happen. B is your accident already has happened. You want to tell whether it happened by bus or not. Okay. So probability B is your accident already has happened. It can happen by bus, it can happen by car, it can happen by bike. These are the three, let's say, vehicles from which accident can happen. So probability of B would be what? Basically, accident. The probabilities of accident happening through each these vehicles. So this is the total probability the accident has happened. Now the question is, what is the probability that the accident has happened and it has happened because of bus? That is probability A given B.
That would be probability of A in like the intersection part. PA intersection B would be P of A into P of B in this case.
Probability B given A into probability A, I guess. That is
okay.
Probability that the accident is happening through bus, probability that it is a bus, and if it's a bus, the accident is happening divided by the probability of all the accidents happening. So if in this case, it would be probability that your economy is generating, probability that your economy is generating poor returns. And if your economy is generating poor returns, what was the probability that your economy was in good state? Is this clear?
Yes.
Okay, coming to reading 5. Reading 5, LOS 5A is calculate and interpret the expected value variance, standard deviation, covariances, and correlation of portfolio returns. Again, very similar to whatever we have done. Expected values, portfolio variances. Just that in here, you will talk about in terms of portfolio returns. So the formula for expected return would be what? You have been given, let's say, return 1, return 2, return 3, up till return n, and the probabilities of each returns have been given to you. So the expected return formula would become return 1 into probability 1 plus return 2 into probability 2 plus return n into probability n. That is summation of I runs from 1 to n, return I into probability I. Okay. And how can you find out this probability? Probability I in case of return can also be given in terms of weightage. What is weightage? Let's say you have 3 types of stocks, A, B, C, and you have 5,000 rupees with you. You are investing rupees 1,000 in this stock, rupees 2,000 in this stock, rupees 2,000 in this stock. The probability of A, the return A will generate is 5%. The return B will generate, A will generate 4%, B will generate 5%, C will generate, let's say, 5.2%. Okay. And so, what are your weightage over here? We can multiply, we can either find the expected values by multiplying it with the probabilities of generating some returns. Here, what is the probability in general? What do we do when we find out the mean? We divide it by the total amount of values we have. When we divide it by the total amount of values we have, what do we assume? That each value has equal chance of occurring each time. That is, if you have 5 values and you're dividing by 5, you say that each value has a chance of occurring, the probability of each value occurring is 1 by 5. So here you have returns. So what is the chance, what is the probability that you are, what is the probability that even if you get 4% return, what is the weightage you are giving to that 4% return in order to get your expected return? You haven't invested the entire 5,000 amount into asset A. So your probability here would be equal to the weight which you are investing into each investment. For asset A, it would be 1,000 by 5,000, 1 by 5. For asset B, it would be 2,000 by 5,000. Similarly, for asset C, it would be 2,000 by 5,000, which is 2 by 5. So here, your expected return is 4% into your 1 by 5, 5% into 2 by 5, 5.2% into 2 by 5. So this is the expected return which you can get if your portfolio composition is like this. After that, coming to covariance. What is the meaning of covariance? Covariance, why do we use this measure? If you have 2 assets and you want to see whether your 2 assets move together or are they moving in the opposite direction. What do I mean by this? If your asset 1 is generating positive returns, whether your asset B is generating positive returns or not, if your asset 1 is generating positive returns, if your asset B is generating negative returns. Mostly we try that whatever assets you have in your portfolio, they should be negatively correlated. Why? Because in that way your portfolio is balanced. Why? Because if one asset is generating negative returns, you have another asset to protect your portfolio's value to be, getting in the negative zone. So if asset B is generating negative return, so if you have negative correlation between the 2 assets, but asset B will generate positive returns and your portfolio value will somewhat remains the same. So what is the covariance formula here? Covariance between the returns Ri and Rj. Ri is, let's say, the returns from asset A. Rj is returns from asset B. Expectation of Ri minus expected value of Ri. Expectation Rj minus expected value of Rj. So it is very similar to which formula? Variance formula. expected return minus expected return whole square. So your covariance formula is expectation of Ri minus expected value of Ri. Expected value of Ri is expected return. Similarly, like say you can be given two assets. We did for one asset A, we had three types of return, 10%, 20%, 20%. We had the probabilities, you had the weightage. We calculated the expected return for A. Similarly, you can be given the components for asset B. You have to find out the expected return of asset B. So here, your equation will be then, you find out the expected value, Ri minus expected value of Rj, Rj minus expected value of Rj. Now, what is your expectation here? What will be the probabilities here? Your probabilities here will be, if you are taking asset A 10%, asset B let's say 20%, and the probability of asset A generating 10% is let's say 5%, asset B generating 20% is let's say 2%. So if you are taking the combination of Ri and Rj here as 10% and 20%, so you will multiply this component with 5% into 2%. Let's do a question for this. Let's say you have asset A. The returns of asset A are 20%, 12%, and 5%. Returns of asset B are 30%, 10%, and 0%. You have been given a question like this. The joint probability of asset A generating 20% and asset B generating 30% has been given as 30%. 12% asset A generating 12%, asset B generating 30% is 0. Asset A generating 5% returns and asset B generating 30% return, this probability is 0. Then asset A generating 20% return and asset B generating 10% return again is 0. This probability is 0.5 that asset A generates 12% return and asset B generates 10% return. Rest again, all these are 0. Asset B generating asset A generating 5% return and asset B generating 0% return is 20% probability. So first we calculate expected return of A and expected return of B before calculating the covariance. What is the expected return of A? You have three types of returns for A, 20%, 12%, 5%. The probability of asset A generating 20% return is what? You add these three probabilities, you get what? 0.3. The first part is 20% into 0.3. Then you have 12% return for asset A. The probabilities are what? 0.50. So the probability is 0.5 into 12%. Then it is 5% into 0.20. 0.20. So what is the answer for expected return of asset A? What is the answer for expected return of asset A? .13. For expected return of asset B, it would be what? 30%, and the probabilities are 0.300. So 30% into 0.3, 10%, and the probabilities are 0.50. 10% into 0.5, 0%, and the probabilities are 0, 0, 0.2. 0% into 0.2. So the expected return of asset B here is 0.4, 1.14. So the covariance would be what? The return of asset A minus the return of asset B, return of asset A minus the expected return into the return of asset B minus the expected return into the probability. So it is 20% minus 13%, 30% minus 14% into probability, which is 30%, add 5%, 50% into 12% minus 13%, 10% minus 14%, plus 0.2, 5% minus 13%, 0% minus 14%. So this is how we can calculate covariance. What will be the variance? We looked at the formula for the covariance. Variance, what will be the formula for variance? Portfolio variance would be to calculate the portfolio variance of portfolio returns. Again, you have two types of assets generating RI returns, RJ returns. You have some weights given. So weight I into weight J, Ri into Rj, you sum double summation, I runs from 1 to n, J runs from 1 to n. What does this mean? Let's say if you have two assets A and B, so you will have two types of returns for A and B. You will have RA and RB. You will have certain amount invested in RA, weight A, certain composition in weight B, which would certain composition in portfolio asset B, which would be WB. So your variance of the portfolio, total portfolio, will be what? I is A, J is A. Weight of A into weight of B, RA into RA. RA square. Sorry, this will be covariance of Ri into Rj. So covariance of RA square is what? Variance of A. Then I is A, J is B. So when I is J, weight A, weight B, covariance of RA, RB plus I is B, J is A. I is B, J is A, covariance of RB, RA. Then your both I and J are B. Weight of B, covariance of RB square. So this is what? Covariance. X square can be written as variance. Because what is the formula for covariance? The formula for covariance was your return minus your expected return into your return minus your expected return. So if both these i's are same, so it is Ri minus expected return whole square. You had your probability here, which is the same as variance formula, variance of the portfolio return formula. So I can write weight square A into variance of A plus, now covariance RA, RB is same as covariance RB, RA. So you can write 2 weight into A, weight of B, covariance RA, RB. Similarly, for this, it would be weight square B, variance of B. Now, this particular equation will also come in portfolio management topic. We have a separate topic from among the 10 subjects. One topic is portfolio management. One entire LOS will be based on portfolio returns, variance of portfolio returns, standard deviation of portfolio returns, covariance of portfolio returns, correlation, and this particular formula. In level 1, portfolio management only has 2 topics. One is little on the theoretical end, and one is where sums are involved. This is one topic, portfolio. Basically summarizing the values of the portfolio. So this particular equation is very important, may not be tested in quants, but will surely be tested in portfolio management. So your sigma square P or variance of the portfolio can be written as this. And what will be the standard deviation of the portfolio? Simply root over this. Hope this is clear. So we had done variance formula, standard deviation formula of the portfolio, expected return of the portfolio, covariance. We are left with correlation of the portfolio. We know correlation of anything is what? Covariance between the returns divided by the standard deviation of the return, A and B. Done this in the last class. Your correlation is equal to your covariance between the returns. So what you will do, you'll first find out the covariance. And why do we move from covariance to correlation? The similar logic which was between variance and standard deviation. Variance has every unit in unit square. If you're finding the variance between returns, your variance will come as percentage square. So it is difficult to interpret something when it is in unit square. So we simply divide it, we root over it, we find out the square root, and we get the standard deviation because it's easier to interpret. If your standard deviation is, let's say, 3.2%, so you can say that, okay, on average, all my random variables are dispersed from my expected value at 3.2%. Similarly, from covariance to correlation we move because covariance always has units in unit square. Covariance has the unit as unit square. If it is percentage, you're finding the covariance between returns. Covariance will have unit as unit percentage square. And correlation is unitless quantity. Why? Your covariance here is percentage square. Your standard deviation of the returns, standard deviation of A and B, portfolio A and B would be what? Percentage into percentage. So your correlation is a unitless quantity. Your covariance tells you how much, whether your securities, your assets are moving together or not. If your covariance is positive, your securities are moving together. If A is increasing, B is increasing. If A is decreasing, B is decreasing. If covariance is negative, your securities are moving in the opposite direction. But it doesn't tell you the intensity. But on the other hand, correlation tells you the intensity. Correlation is always between -1 to 1. So if your correlation is -1, you can say that your securities are perfectly negatively correlated. So if your security 1 will move by -5%, security 2 is going to move by +5%. And if your correlation is 1, you can say that your securities are perfectly positively correlated. And if they are between, closer to -1 and 1, you can say it is strongly negatively correlated or positively correlated, whatever the situation is. So your formula for correlation is covariance A, B by standard deviation of A into standard deviation of B. Coming to LOS 5C. So LOS 5C is shortfall risk safety first criterion. So what is shortfall risk? Shortfall risk is a probability that portfolio value will fall below some target level. Let's say you have, the company has decided that 50,000 crore is my 50,000 crore is my level, beyond which if my total asset value, if they goes, then I am at a risk. So the probabilities are defined. Probabilities of your asset value being, let's say, 40,000 crores is defined. Your asset value being 30,000 crores is defined. Your asset value being 10,000 crores is defined. And in the question, it may ask, what is the shortfall probability of your portfolio value or the company's value hitting below this target level? So what is the solution for this? You have your probabilities, let's say x1, x2, x3, or 20%, 10%, 5%. So the shortfall risk or the shortfall probability is simply the summation of these three probabilities. Maybe you have been given in the question that find out the shortfall risk of my portfolio hitting negative returns. So your question may have probabilities like 30%, 20%, 0%, minus 10%, minus 20%. So these are the returns which your portfolio can generate, and the probability of each type of return is given: 40%, 30%, 10%, 5%, 40, 70, 80, 85, 15%. So what is the shortfall risk of my portfolio hitting negative returns? So we simply just add these two values, because beyond the zero level, there are only two negative returns, and the probability of these two is 20%. 5% plus 15%, which is 20%. So this is how we calculate shortfall risk. After that, you have Roy's safety first criterion. Optimal portfolio minimizes the probability that the return of a portfolio falls below some minimum acceptable level. The Roy's safety first criterion tells you what is optimal portfolio. An optimal portfolio is the portfolio which will minimize the probability that the return of your portfolio will fall below some minimum acceptable level. So very similar to the safety first, very similar to the shortfall risk, whatever we discussed, shortfall probability, that you have some certain level of acceptable level, beyond which what is the probability that your portfolio will hit. So Roy's safety first criterion tells you that your optimal portfolio will always minimize the probability that your return of the portfolio will fall below some minimum acceptable level. That is, let's say RP is the return of the portfolio and RL is the minimum acceptable level. Your Royal Safety First criterion tells you that your optimal portfolio will minimize this probability. The probability that your return of the portfolio will be less than the return, minimum acceptable level. The Royal Safety First criterion will minimize this probability. Clear? So you first calculate the safety first ratio, which is your expected return of the portfolio minus the minimum acceptable level by the sigma of P. So you calculate the expected return of the portfolio, you subtract the minimum acceptable level of the return, you divide it by the standard deviation of the portfolio. Then we choose the portfolio that has the largest safety first ratio. So the optimal portfolio is a portfolio which has the largest safety first ratio. So if portfolio A has, let's say, 1.2 ratio and portfolio 2 has 0.8 safety first ratio, you will go with option A because it has largest safety first ratio. What does this mean? That your ERP minus RL divided by sigma P, this should be greater when you are choosing the optimal portfolio. When you are dividing something by the standard deviation, it means what? How much level, how much units is your this return away from the mean? You're calculating that how much standard deviations below the mean. Your expected return of the portfolio, your expected return or your RN, whatever is your expected return, that is your mean, and your minimum acceptable level, you find out the difference and you divide it by standard deviation, which tells you how much your, whatever your expected value is, your level, your acceptable level, how much far away it is from your standard deviation. The greater it is far away from your standard deviation, the greater it is below your standard deviation. Let's say your mean is 3.8 and your expected level is 1.2. 3.8 minus 1.2, the far away it is from your standard deviation, there are less chances for you to be falling below this acceptable level. The difference, this numerator of the safety first ratio calculates this difference, the difference between your expected value of the portfolio and the safety first ratio. And the greater your expected value is from your minimum acceptable level, the lesser are the chances that you are going to hit the acceptable level. Moving to LOS 6A, reading 6, simulation methods. This reading is on a theoretical side. reading 6, LOS 6A, which is relationship between log normal and normal distribution. And why log normal distribution is used to model asset prices when using why log normal distribution used to model asset prices when using continuously compounded returns. So what is log normal distribution? Log normal distribution, you generate it with the function e to the power x, where your x is normally distributed. So if you have a distribution x, and if you take the exponential of that, you get your log normal distribution. And because ln of e to the power x is equal to x, which is normally distributed, because ln and e neutralize each other, logarithms of log normal distribution follow normal distribution. An important line. Log normal distribution we form by how? You take e to the power x, exponential to the power x, where your x is following normal distribution. When you take logarithms of e to the power x, where your x is following normal distribution, ln and e will neutralize each other. So logarithms of all the log normal distribution follows normal distribution. So if this is your normal distribution, your log normal distribution somewhat looks like this. If your asset prices are generating continuously compounded returns, we use log normal distribution in order to find out the future returns. That is, PT is my price of the asset at time t. T0 is the price of my asset at time 0. E to the power r 0 to t. Now, if your returns are IID, that means identical and independent and identically distributed. This means what? If your returns are independent, this means if that your today's return is independent of your past returns. Whatever happened in the past, you cannot use it to generate. You cannot use it to guess what will happen in the future, how my future returns would look like. Identically distributed means what? If your past returns were following normal distribution, your today's return will also follow normal distribution. That is the different types of distribution. Let's say you have Ri, R1, R2, R3 up till Rn. If these are independent and identically distributed, you can say that the return Ri is independent of R2. Whatever is happening in R2, that will not affect R1. And if R1 is following log normal distribution, then all the distributions will follow, all the returns will follow log normal distribution. If R1 is following normal distribution, all the returns will follow normal distribution. LOSB is LOS6B is Monte Carlo distribution. Monte Carlo simulation. What is Monte Carlo simulation? So the steps are, you specify the probability of stock prices and relevant interest rates, whatever parameters are there, randomly generate values, value the options for each pair of risk factor, calculate mean value. So what happens is, what does Monte Carlo simulation do? You have, let's say, you have the asset prices and you have the parameters upon which the asset prices will be affected by. So you define the distribution of each of these parameters. You define the distribution of your asset price. Let's say my asset price is following Lognormal distribution. Normal distribution. My rate of returns, continuously compounded rate of returns, are following Lognormal distribution, and there are other parameters as well. How the political scenario of the world will be like. There are other scenarios that we are not considering in our calculation because we assume that maybe those will not affect my price that much. So I take whatever factors are there. I define distribution for my prices. I define distribution for my rate of interest. I will define the parameters, mean, variance, whatever is needed. If you take log-normal distribution, you have to define a mu sigma square for the log-normal distribution. You define the normal distributions parameters, and you will generate runs. That is, first run, you will get certain set of distribution of the prices. You'll get certain set of distribution for the rates. You have defined the log-normal distribution. So from that log-normal distribution, you will generate some certain run, and you will get certain set of rate of returns from that log-normal distribution with the mu and sigma square, and you will get certain set of prices. You will generate a second run. Again, you will get some price. Again, you will get some, values. You will continue till like this. The number of runs, whatever number of runs you do. Let's say you take 5 runs or you take 10 runs. When you take 5 runs, you will have 5 average out values. You will get, let's say in each 5 runs, you are extracting 100 values each time. So you'll find the average values for the 5 runs and you'll average out them, and then you'll get some certain expected price. But if you do the run for 10 times, you will have greater certainty. The many times you do this run for the Monte Carlo simulation, the more values will be generated and the more certain your price can be. So what are the disadvantages for Monte Carlo simulation? It requires huge computational power. You will it cannot be done manually. You will require computer for this, and it's a little complex process. And what are the advantages of this model? Your inputs are not constricted to what your historical values are. You can define a distribution that I believe my rate of return is supposed to be following log-normal distribution with parameters this. So there's a greater chance that whatever expected values you are predicting that are for sure maybe going to happen. There's a greater chance that your values are true. because you are not restricting yourself to the past, to the history. The second type of simulation, which is LOS 6C, is resampling. So it can be the case that you do not have the population. Let's say you are doing a study of 50 years back or 100 years back, and whatever you are doing the study on, you do not have the population of that time, which is very obvious or very reasonable also. So you sort of get some certain samples. Now you have one sample, sample A. This is not the whole population which was existing at that time. You did some certain questionnaires and you were able to get some certain sample. Now, what does resampling process do? Resampling takes out subsamples from this sample. That is, let's say you define that you have 100 people's opinion in this sample. You say that after, in my resampling, I'll take out 20 random samples from this sample. Then you draw 20 random samples each time. You draw 20 people's opinion. You formulate whatever values you want to calculate, expected value, return, everything. You calculate your expectations mean. You drop these opinions back. Then again, you randomly, pick out 20 people's opinion. You you calculate all your numbers. So you will have different numbers. You can have as many subsamples you want. The many subsamples, the more subsamples you have, the more precise your calculations will be. So you get different types of means. So you average out the expected values. Then you will get your final expected value. So this is how resampling is done. Now the drawback of the resampling is you are very much restricted to the historical values. Whatever sample you have, you are basing your whole calculations on that. So if your sample is spurious, if your sample is, not very exact, so whatever your results will be, that will also be incorrect. And what is the advantage? It's easier when compared to Monte Carlo simulation. Going to reading 7. We'll take a 2 minutes break. So let's start with reading 7. You have 7A, LOS 7A. Compare and contrast simple random, stratified random, cluster, convenience, judgmental sampling. So these are the different types of sampling processes. You may be given a certain type of situation and you may be asked that what type of sampling process is this. First, we'll start with probability sampling. It means you are selecting sample when you know the probability of each sample in overall population. This means that you know that there are around, let's say you have 100 people and you want to select, you have 100 assets and you want to select, let's say 10 assets from these 100 assets. And you know that among the 100 assets, there are around 20 assets that are similar to each other, 30 assets that are similar to each other, 5 assets that are similar to each other, and so on. You know the groups as well. So you know the probability with which you will be selecting the sample. You know the population altogether. So you are selecting the sample when you know the probability of sample in overall population. You know the population. You know what type of sampling you are doing. When you are doing random sampling, this is under probability sampling as only. Meaning of random sampling is you are picking out the samples randomly. Here, you are not assigning any specific, probability to any of the values. Let's say you are simply drawing 10 assets from the 100 assets. Continuing our example, so you are not attaching any specific probability to any asset. That is, all assets have equal chance of coming up in your sample. No asset is being prioritized to other asset. So you are just randomly picking out your sample. Then comes non-probability sampling. Here it is based on low cost judgments. Here no probability is involved. Here it is not the thing that you are assigning some probability to some samples and you're picking out samples on the basis of that, or you are randomly just picking out the samples. You are assuming that each value in your sample, in your population, has equal chance of coming up in your sample. Here it is more of like you didn't get any sample. It was difficult to extract any sample for any research. So whatever sample was available to you, whatever on convenience basis, whatever sample was available to you, you chose that sample, or you used your judgment in order to form that sample. That according to my previous experience, I believe that these stocks are the best. So there was no probability involved, or you used the sample which was available at some low cost. So in non-probability sampling, there are greater judgments involved. So there are greater chances that there will be deviations from your overall total population. So your first probability sampling methods. The first method is simple random sampling. Simplest of all, that is, you are randomly picking out samples from your overall population. If you have, let's say, 10 apples and you want to pick out 5 apples from them, and you know that those 10 apples are covered in some box, and you're just randomly picking out 5 apples. So you are not prioritizing any apple over another apple to another apple. Each sample of yours has equal chance of coming up in your sample. Each value has equal chance. This is simple random sampling. Then you have systematic sampling. That is, let's say you have 100 stocks and you want to pick up 15 stocks. So you say that after every 3 stocks, I'll be picking up the 4th stock. So you find a system in order to select the stocks. That is, let's say after every 3 stocks, I will be skipping the 4th stock. And if that 4th stock, let's say, had generated good returns in the past, so I'll be picking up that stock, or I'll be moving to 5th stock. So you form certain type of system, certain type of mechanism with which you will be selecting your sample. Then comes stratified sampling. Here you do what? You make stratas. That is, you know your population. Your population has certain characteristics. Let's say you are making a sample of bonds. For bonds, what are the different types of characteristics bonds can have? The coupon rates can differ. The tenure can differ. Tenure of the bonds can differ. So let's say you are making stratas on the basis of tenure of the bonds, that these are my short-term bonds, 1-year bonds. These are my medium-term bonds, 2 to 3 year bonds. These are my, sort of long-term bonds, 5 to 10 year bonds. And these are my very long-term bonds up till 10 to 20 years bond. So you make up these stratas. So you have 4 different stratas. Now you pick up, certain random samples from these stratas, and then you form your main sample. So you first divide your whole population into different stratas, then you pick up random samples from these stratas, and you do the sampling. The final sample is based on these stratas. Then become cluster sampling. The cluster sampling and stratified sampling may look very similar, but the difference between them is, in clusters, what you do, you have your whole population, you divide your whole population into different clusters. Similar to what stratified sampling was doing, you had your whole population, you divided them into different groups. Now, the difference between stratified sampling and cluster sampling is, in stratified sampling, you are assuming that you are forming stratas, that each strata which you are forming has a particular characteristic which is different from the other strata. In cluster sampling, the whole population is divided into clusters, and each cluster is assumed to be representative of the whole population. This cluster is no different than this cluster. This cluster is no different than this cluster. And this is also similar to this cluster. So here, how you will be doing the sampling, you have divided the population into different clusters. You will simply be picking up this cluster as your sample. And you will proceed with your sampling. That is, you will form this cluster. You will include all the type of people, let's say, all the type of bonds which could have been there. You include one bond with a very short tenure, one bond with short tenure, medium bond, long-term bond, and very long-term bond. In each cluster, all these types of bonds are present. So you can choose any cluster and do your sampling. And in stratified sampling, each strata contains bonds which have some particular characteristic. So you do not take up each strata and start with your sampling. You select some bonds from each stratas and then make your final sample. Now, two-stage clustering is somewhat similar to what stratified sampling is. In two-stage clustering, what we do, you have divided your whole population into different clusters. Now, you have, let's say, 4 clusters with you. You will again, let's say, choose certain people, just like we had done in stratified sampling, that first we divided our whole population into different stratas. After dividing the whole population into different stratas, I picked out some people from these stratas and then formed my whole sample. Now, in two-stage clustering is, first you divide your whole population into different clusters, then again you choose certain people from each cluster and form your sample. So this was probability sampling methods: simple random sampling, systematic sampling, stratified sampling, cluster sampling, two-stage clustering. Coming to non-probability sampling methods. First is convenience sampling. As the name suggests, you form your sample on the basis of ease of data. Whatever data you can find, let's say you, again continuing with the example that you are trying to do a research based on certain 100 years ago. So it's impractical to assume that you may be able to get a lot of information. So what you do convenience sampling. Whatever data I'm getting, on the basis of that data, I'll be continuing with my research. So this is convenience sampling, ease of data access. Then comes judgmental sampling. What happens in judgmental sampling? Let's say you use your judgments in order to find the sample, in order to make the sample. You are doing the analysis of some reports, okay? And you find out that there are certain, mismatch over and here. Whatever the company is reporting, that is not the true picture. The company is not reflecting the true and fair picture. This shouldn't have been the case. So now you are analyzing. You have different types of ratios. You have different types of, accounting statements, different types of accounts which you can look into. So there are many things which you can study. So you need to figure out something that from whole lot of information, you need to reduce the type of information you want to look at in order to, analyze where the company is going wrong. So okay, this is what the company is doing, and based on your judgments, you make that decision that, okay, these are the certain types of ratios, these 4 ratios, surely the company must be misinterpreting or misreporting, and these are the 2 types of accounts, 3 types of accounts I need to look into, because I believe the company is maybe manipulating these 3 types of accounts. Basis on your judgment, you make this sample. You are not doing any convenience sampling. You are not waiting, okay, that this is the easy way of data, easiest data which I can get. So let's continue with that. You are not randomly picking out the accounts. Neither are you randomly selecting the ratios. You are using your judgments that according to my previous, judgment. These are the ratios which the company may be misreporting. These are the accounts which the company may be misreporting. So you pick out these 7 datas and make your sample. So this is judgmental sampling. Going to reading 7b, LOS 7b. Explain the central limit theorem. And its importance for the distribution and standard error of the sample mean. The central limit theorem states that for simple random samples of size n from a population with mean mu finite, the word finite is very important here, finite variance sigma square, the sampling distribution of the sample mean x approaches to a normal distribution with mean mu variance equal to sigma square by n as sample size increases. So your CLT states that for a simple random sample, no type of other samples, your sample should have been drawn, in the random sampling way. That is, each value from your population has an equal chance of occurring in your sample of size n. From a population, the mean of the population is mu, and the finite variance of the population is sigma square. Here, the CRT states that you have a simple random sample with the size n, which has been drawn from a population. The characteristic of the population is it has mean mu and the finite variance sigma square. The sampling distribution of the sample mean, that is, you will form a sample. The sampling distribution, that is the distribution of that sample mean. Your sample, the mean, whatever mean of your sample will be, that the distribution of that sample mean will follow a normal distribution. Your sample mean will follow a normal distribution with mean mu and variance sigma square by n as your sample size increases. So if your sample size keeps on increasing, then your sample mean will follow normal mu comma sigma square by n. Now, what are the important properties here? Your n is sufficiently large. This will only happen if, number one, your n is sufficiently large, which means your n is greater than equal to 30, Whatever your population size is, your sample should be, the number of values you have in your sample should be either equal to or greater than 30. Then the mean of the population mu and the mean of all the samples are equal. And the third being, you are dividing your population variance by the sample size. What is standard error of the sample mean? We know the variance is sigma squared by n. The standard error would be what? Sigma by root n. Root over sigma squared by n is the standard error of the sample mean. But in most cases, sigma would not be known. Sigma is our population variance. So if you do not know the population variance, you will substitute it by S, where S is your sample variance. So S is your standard deviation of sample. So in most cases, you would not know what the population standard deviation population deviation is. So you substitute with it by S, where S is your standard deviation of sample. So let's start with LOS 7C. Which is describe the use of resampling. To estimate the sampling distribution of a statistic. So previously, we used the sample variance to calculate standard error of our estimate of the mean. So whatever our standard error of the estimate of the mean we were calculating, Sx, that was equal to sigma by root n. The standard error provides better estimates of the distribution of sample mean when the sample is unbiased. This would provide better estimates when your sample is unbiased. That is, there are no judgments involved. Each value had equal probability of coming up in your sample, and distribution of sample means is approximately normal. Two alternative methods of estimating the standard error of the sample mean involve, so you can approximate the standard error of the sample mean by two different methods beyond this. It will involve resampling of the data. Resampling of the data, what does it mean? You have the sample, you pick out certain samples, like let's say your population had 1,000 assets. You made a sample of 100 assets. Now from 100 assets, again you are making a sample of 10 assets. 10 assets, you are resampling the, making again sub-samples of each sample containing 10 assets. So you are picking out samples from your sample. So the first of this is Jackknife method. What does Jackknife method does? It calculates multiple sample means And how does it do that? You have your sample, you have 100 values in your sample. Each time you will remove one value. After removing one value, what is your sample mean? Again, in the second run, you will remove the second value. What is your sample mean? So like this Jack sample calculates multiple sample means. So the standard deviation of these sample means can then be used as standard error of sample means. So you have calculated multiple sample means by removing each value from your sample each time. You have multiple sample means. So if you have, let's say, 5 values in your sample mean, so you remove the first value, you will have one sample mean, remove the second value, one sample mean, third sample mean, fourth, you will have 5 sample means here. You'll have 5 different sample means. So you can then calculate the standard deviation of these sample means and then calculate standard error of the sample means. So this method is what? It is computationally very easy. It's not very complex to understand, and if you have a small amount of sample, let's say if your sample is only involves only 10 assets, then it's easier to do. But with 100 or 1,000 amount of sample, when your n is 100 or 1,000, it's comparatively at a difficult end. And how does it help us? It helps us to remove bias from statistical estimates. Whatever standard error you are calculating, this standard error is a statistical estimate. We are estimating that, okay, it should be equal to the population variance by the root n only when your distribution of sample mean is approximately equal to the normal distribution. So it involves certain bias because you are assuming that it follows normal distribution. So this method helps us to remove the bias from the statistical estimates which we are calculating. Then you have bootstrap method. Now, bootstrap method, involves more computational complexity when compared to the jackknife method. What does bootstrap method do? You will have your whole population, not one population, whole population. And from this whole population, you will decide that, okay, I want n size of sample. So you will bootstrap this n size of sample for, let's say, 10 times. So you will have 10 different samples of size n. So then now you can calculate the sample mean, standard error, and so on. So the difference between bootstrap and jackknife was what? In jackknife, you had a sample, and from that sample you were resampling. But from bootstrap, we extract 10 different samples from the population itself. So bootstrap sample, as it suggests, it's a little complex when compared to jackknife, but bootstrap sample will give better predictability power than jackknife because of the complexities involved. Coming to reading 8, we'll not start much of reading 8 today. Just cover up the basics, because reading 8 and reading 9 are somewhat related. So reading 8 is hypothesis testing. Explain hypothesis testing. LOS 8A is explain the hypothesis testing, what the components are, including the statistical significance, type 1, type 2 errors, and the power of a test. The LOSs are very important. Do read the LOS before you start reading anything, because many times there are many topics which are included in the readings, but that won't really be tested in the exam. So when you are going through the whole concept or the whole topics, it's wise that you go through everything and understand everything. But during the end of your preparations, when you're just revising everything, then pay attention to the LOS, because whatever is mentioned in the LOS, that only will be tested. So explain hypothesis testing. A hypothesis is a statement about the value of a population parameter. Statement about what? About the value of a population parameter developed for the purpose of testing or belief. So, let's say you are doing a study. We are doing a study that whether our population parameter is equal to this or not equal to this, or if it is greater than this or not greater than this, whether the mean of all the people who are smoking is greater than 0.5 or not greater than 0.5. Like 50% of the people are smoking or not smoking in my population. If we are doing this type of research, this type of study, when you want to make a conclusion about your whole population, whenever we will be, even if we, do any, how do I say it? Research paper. Whenever you do any research paper, what we are doing, you either do your research on the basis of the data which is already published, that is primary source, or you go on to the secondary source, that is you interview people, you roll out your questionnaires, then whatever answers you are getting, you form your questions on the basis of that, then you form certain type of hypothesis which you want to test, that whether, let's say if your research question was starting with something that internet, the AI will, whatever AI is helping people in studying or not studying. So you will have your research questions based on that, or you may be having a study. You may refer to that study as well, primary source of data. Then you will be doing your calculations. You'll be forming different types of samples, different types of population mean, standard deviation, everything. You will have your estimates. Then you will have your hypothesis. Okay, if this is equal to this, or this is greater than this, then I can conclude that AI is helping people. AI is doing this. So for each questions, maybe you can do a hypothesis testing and continue with your, research. So therein, you are forming a statement about the value of a population parameter. This parameter can be anything. It can be a mean, standard deviation, correlation, anything. That whether AI and my studies are correlated or not. If they are correlated, are they strongly correlated, equal to 1 or not equal to 1? So you can form a hypothesis about a population parameter which you want to study, developed for the purpose of testing or belief. Okay. Hypotheses are stated in terms of population parameters to be tested, like population mean, mu. So how do you state a hypothesis? You will state a hypothesis based on the population parameter which we want to test, like a population parameter mu. So what is the process of hypothesis testing? So hypothesis is basically a statement which regards your population, which contains a population parameter, and you state your belief regarding that population parameter. So the process is, first you state the hypothesis. What do you want to test about your population parameter? Let's say I want to test whether my mu is greater than 0 or not greater than 0. So first you test your population parameter. Then you select the appropriate test statistic. We'll come to this. Test statistic is something which, test statistic is something upon which you will be basing your research. That what is, if that value of the test statistic is greater than my value, critical value, or if my test statistic value is less than the critical value, then on the basis of that, we will be coming to our final conclusions. Then you select your significance level. That is, you want your testing to be done on 1% level, 5% level, 10% level. When you are, that is, if you want your testing to be done on 1% level, that means what? You want to be 99% sure that my results should be true. If you do your significance studies at 5% level, that is at 95% significance level, you want to be 95% sure that whatever research you are doing, that is true. So you select what your significance level will be, because on the basis of the significance level, your critical values will, change. If you are selecting 1%, 99% significance level, or then whatever your critical values are, that that will be testing your test statistic even more strongly. Then comes state the decision rule regarding your hypothesis. Collect the sample. State the decision rules mean that if my test statistic is greater than my critical value, this is my decision. If my test statistic is less than the critical value, this is my decision. Then you collect the sample and calculate sample statistic. Make a decision regarding the hypothesis. Make a decision based on the results of the test. So this is the entire process which needs to be followed. You first state the hypothesis, then you state what your appropriate test statistic is, then you select your significance level, then you state your decision rule, collect the sample, calculate the sample statistic, make a decision regarding the hypothesis, and make a decision based on the results of the test. So the first component of your hypothesis testing, these definitions are tested in exam. What is null hypothesis? What is alternative hypothesis? Directly you may get a question. So what is null hypothesis? We denote null hypothesis as H naught. This is the hypothesis that the researcher wants to reject. The question can directly come, what is the hypothesis which the researcher wants to reject? That is the null hypothesis, and direct questions do come. The first definition is, this is the hypothesis that the researcher would want to reject. You would want to reject this hypothesis. It is the hypothesis that is actually tested. This is based on what you actually want to test. This is the basis for the selection of test statistics. It is a simple statement about population parameter. It always includes the equal to sign. So, null hypothesis is the hypothesis which the researcher wants to reject. The researcher would want to reject this hypothesis, and it is the hypothesis which we are actually testing. Our whole testing will be based on the null hypothesis and not alternative hypothesis. We use this hypothesis in order to form the test statistic, and it is a very simple statement about the population parameter. You include the population parameter on your null hypothesis, and your null hypothesis will always involve the equal to sign. That is, let's say you are making an assumption about your population parameter that whether it is equal to mu naught or not equal to mu naught. So what is your H naught here? Mu is equal to mu naught. Then the alternative hypothesis, which is denoted as HA, is what is concluded. It is concluded if there is sufficient evidence to reject the null hypothesis and is usually what you are trying to assess. So your null hypothesis is the hypothesis which you want to reject, and it is actually tested. Whatever your test statistics are, whatever your testings would be, it would be entirely done on null hypothesis. It will involve a population parameter statement and always has the equal to sign. And whatever your alternative hypothesis is, it is actually what you were looking for, trying to assess. That is, you were looking to assess whether the mean of all the people who are smoking is greater than 50% or not. But since you cannot assess this 50%, mean is greater than 50%, you form a null hypothesis, and if you have certain evidence, significant evidence to reject the null hypothesis, then you conclude that your alternative hypothesis is true. So you have your null hypothesis which you want to reject. Your testing is based on your null hypothesis. And if you have certain evidence to reject your null hypothesis, then you conclude that your alternative hypothesis was true, and your alternative hypothesis is the one which we were trying to assess. We were trying to assess that whether, my population parameter was greater than this or not greater than this. So this is this. Now, if your mu is equal to mu naught, is your H naught, then your alternative hypothesis would be what? Mu is not equal to mu naught. What your null hypothesis and alternative hypothesis are mutually exclusive and exhaustive. The meaning is, whatever the values are possible under the sun, all the values are included in both the hypothesis. There is nothing beyond this which remains. If mu is not equal to mu naught, then we can simply conclude that if mu is not equal to mu naught, then if we have certain evidence to reject this, then we conclude this, that mu is not equal to mu naught. So all the values are coming. That is, they are exhaustive. And in no case, there can be a situation that you are in a position to conclude both the statements, that mu is equal to mu naught and mu is not equal to mu naught as well. There are no values which will satisfy both the alternative hypothesis and the null hypothesis. So let's keep it till here. We'll come to the decision rule type 1 error in the next class tomorrow, and we'll try to wrap up Quant's revision classes and do some questions based on whatever topics we have discussed till now.